Hello everyone, our algorithm is based on search and does not use neural networks and deep learning. Our algorithm is mainly divided into the following 4 steps. The first is to construct a fake game environment based on the JSON. It is different from the training environment. It is incomplete information, and it can also do some illegal operations to simulate. The second is to generate current legal actions in the fake game environment. The legal action must be very accurate. If it's too much, it will lead us to a loss. If it's not enough, the AI will not be strong. The third is to search for all legal actions in a fake game environment. We use recursion and shunting algorithm. Finally, we add mailing tricks in the algorithm, and our algorithm also have a lot of weaknesses. And this page shows how we use JSON to building the fake environment. Firstly, we initialize the variables like my position, round wind, and hand tiles claimings, and round stage, and so on. And second, we load the JSON line by line. In every line, we do the step the JSON. We do the step the JSON shows to us. And finally, when the JSON is ended, we can get our observation. After getting the states, we need to precise legal actions. Here we judge pass, play, 支, pawn, 杠, 补杠, and 胡 in turn. When judging who, the official calculator is used, and when we can who, we do it. Our search algorithm uses a shunting algorithm library. The shunting algorithm's Android APK is shown on the right, and its source code can be downloaded and built to a SO. Our input is hand tiles and claimings, and the count of hand tiles must mostly equal to 1, which is different from the picture. The picture have 14 tiles, and we do not need the last one. And the shunting library's output is the distance from the input's distance from 5 types of who, and which tiles can make the distance -1. That means which tiles we need. The 5 types of who is 1317对，全不靠，组合龙 and a general who. The process of recursive iteration is as follows 4 steps. Firstly, we traverse all legal actions and execute them. After doing them, the number of cards in a hand will be mod 3 equal to 1, and we can input our state to the Shanting library. The step 2 is when we get the Shanting library's output, we find the smallest distance. In the picture is general type of hole. The distance is 1. And step 3, in a fake environment, we assume that we draw the corresponding card. For example, in the picture is 3M, 6M, and 9M and F. Then we repeat to step 1. We now have other legal actions and do them and so on. And step 4 is when we stimulation to Hu, we get a reward, means we win, and we return the reward to current node according to the probability. Last page we show our tricks and weaknesses. The first trick is we add a constant reward to smooth the fun, because if a fun is 8, when we self-draw, we'll earn 14.8 reward. But if the fun is 24, we self-draw, we'll receive 19.6 reward. It's double. But when we not win, we will not receive 0 reward. We will receive a minus reward, and we assume that the minus reward is 14.3. And the second is when we search to Hu, we make the probability of 26% self-draw and 74 discarded by another player. Third is when not search to Hu. You know the game Hu at least 8 fun. When we not search to Hu, we assume the general type Hu has a 13.6% probability to more than 8 fun. And then when we try to Hu 组合龙 or general type, we play the 字 firstly. When we try to Hu 1317队 and 全部靠, we play 字 lastly. When we search to Hu but the fun is less than 8, we cannot Hu, so make this path distance too big enough and search other paths. When a tile is observed 2 times, we can consider a little probability to Hu last tile, means Hu 绝招. And when we have 3 claimants, we consider probability to Hu 全球人. And we save the node we searched, and so we can next time we search to this node, we know the result. The if time up, we use the artificial value function. Our main weakness is that no consideration of transfer at the same distance. We only search a transfer to the smaller distance, and no consideration of opponent's cards, and no consideration of defense. And our search is not effective. So at most time, the distance is more than 3, we cannot search to foo and use artificial value function.